The conventional way to monitor a motor is to use a current transformer to measure the amperage draw on the motor. Power is measured in horsepower and is calculated by multiplying the voltage and amperage draw. At less than 100% load on the motor, the voltage and amperage draw are out of phase. This slide rule calculator allows you to follow the relationship between the phase difference between voltage and amp draw. The red values shown are representative of a typical motor and how it responds to load changes. Notice as we begin to move the slide to the left, we begin to see that the change between the amp draw and the power factor in this particular example is about 15%. Let's watch how those changes occur as we begin to increase the load on the motor. Further pulling to the left, we notice now that difference is about 10%. The next slide, we're down to 2%. But as we move to further load on the mode, we're back into about an 18% difference in this example. And when the two are finally in phase, the amp draw and power factor are at the same or the motor's at full load. Power monitoring provides a longer linear curve, which is shown on the left, and you compare that to the curve on the right, which is measuring only amp draw. Notice that you've only got a very short area where you can profile and understand what's going on with the relationship between voltage, amperage draw, and therefore horsepower on the motor. A load control device, which is shown here as one example, has the ability to measure both the amp draw as well as the voltage, and then provide through a calculation the horsepower that the motor is providing to the equipment it's powering. By first profiling the motor to see what is normal operation, you can then program in up to 3 set points in a typical load control unit, which will allow you to alarm, monitor, or quite frankly do whatever else you'd like to do to warn you that you've got a problem with either a failure beginning to occur in the motor, such as bearings, or you've got a problem in the equipment that the motor is driving with something going wrong with that equipment. The bottom line is that it provides you a way to, first of all, reduce power consumption by addressing issues where motor loads are induced by wear and tear on equipment, but more importantly, it also warns you that before catastrophic failure occurs, either to the motor or the equipment you're powering, you can avoid costly repair bills. If you're interested in getting a free slide rule calculator so that you can sort of look at the numbers going back and forth and understand the relationship, just click the link below and we'll be more than happy to send you one.